Hi everyone, welcome to our channel. So today video is on implementing clean architecture and CQRS mediator pattern into our .NET 7 Web API. So this is a diagram on clean architecture. Actually, if we use clean architecture, we need to create 4 projects. One is domain layer, second one is application layer, third one is infrastructure layer, and fourth one is UI layer. Okay, so domain layer is the individual project, means it will not depend upon any other project. Okay, it is like a root, it sits on the top. Next, so domain layer contains like entities. In our case, if you use entity framework or code first approach, we need to create table classes, right? All those plain table classes will go under domain layer. Okay, that is about domain layer. So application layer is like we can write our services or business logics. In general, it contains like business logic files. If you implement CQRS mediator, then CQRS files, okay, and interfaces and any automapper profiles, any validations if you want to apply, those validations can be written in application layer. Next, coming to infrastructure layer, it is like we implement logic like database communication, means creating a DB context or HTTP client calls, third party API calls, or something like sending emails, all related to some kind of job related things goes under infrastructure. And UI layer means any API, MVC, Razor, all this comes under UI layer. Okay, so in general, we know about entire architecture, right? In entire architecture, we usually consume infrastructure layer into application layer. But in clean architecture, it is reverse. Infrastructure layer itself depends upon the application layer. That is the main mechanism of the clean architecture. So what is this inversion helps means it will give more flexibility for testing the code. Okay. So here is the description what I have explained till now. Let's go again. The clean architecture comprises of 4 applications like domain layer, application layer, infrastructure layer, and UI layer. Okay. So clean architecture lives on the dependency inversion principle I just mentioned, right? Infrastructure layer depends upon the application layer, which is a reverse when we compare with our entire architecture or monolithic architecture, any kind of architecture. Okay. In general, business logic depends upon the data access layer or infrastructure layer. But in the clean architecture, it is inverted, which means data access layer can be depends upon the business logic layer. So with this inversion approach, we can use any kind of data access layer. Means you can use a DB context. If you don't want, you can use a repository there. And it can be easily integrated into our business logic. Okay. And now domain layer. The domain layer is a project that will have entities we discussed, right? And domain services, any services that related to entity and any valuation objects. Okay. This project is a parent project and it is independent of all projects. So domain layer can be like a shared one. So it will not depend upon any project. Next, application layer. The application layer is a project that contains business logic files, your DTO files, mappers, validators, etc. And this application depends only on domain layer. Okay. Next, coming to the infrastructure layer. Infrastructure layer project contains database logic or external API calls, email sending or logging techniques. Okay, this project depends upon both the domain layer and application layer. Okay, and next final UI layer. Layer project means MVC, Razor page, Web API. All these users get response, right? Those projects comes under UI layer. Okay. Actually, this UI layer only consumes the code inside of the application layer. That means it is technically only depends on the application layer. But we reference or we add infrastructure layer also into the UI layer. That is because the DI to use the dependency injection or to register the infrastructure dependency injection, we will import the infrastructure into UI layer. Other than that, we cannot consume any code or logic from the infrastructure layer directly into the UI layer. It should always consume the logical files of the application layer. Okay. Now it is time to create a small sample application that can describe our clean architecture. Okay, here is one point. The .NET 7 application can be created either using Visual Studio 2022 or you can use .NET CLI commands. Here in my case, I am using the .NET CLI commands, okay? But if you have Visual Studio 2022, which is the latest version, please go with that, okay? I have to create a solution file, okay? Here is the CLI command for creating a solution file, okay? .NET space new space CLN and space -n. That means flag represents specify the name of the project. Okay. Next to the -n, we have to specify the project name. Here I specified my project name like .NET 7 clean architecture. So let me create my solution file. Okay. And here you can see solution file got added for me. Okay. Now we have to create 4 projects. In that, 3 are class library and 1 is web API. Okay, first let me create the project based on our clean architecture layer. Okay, okay. First, let's create a class library that represents our domain layer. Okay, here is my command. .NET space new space class library -o represents output directory and name of my project. I named like .NET 7 clean architecture domain. So this class library I am going to use it as my domain layer project. So create it. And here you can see the domain layer project gets created for me. Next, I am going to create one more class library project that represents our application layer. Okay, here is my command .NET space new space class library space -o output directory and name of my project. And name of my project is .NET 7 clean architecture application. Okay, so now I done creating application layer project as well. So next, let me create one more class library project that is infrastructure project. Okay. Okay. As usual, same command for creating a class library, but the project name I have given like .NET 7 clean architecture infrastructure. Okay. Let me create it. Okay. Now I have created 3 class libraries. Okay. Now let me create one more project that is web API. Okay, this is my command to create the web API project. That is .NET space new space web API space -o that represents output directory and the name of the application. So finally, if you look at the folder and projects inside of it, it will represent our entire diagram, right? So domain, application, infrastructure, and UI layer. Here also I did same. That means we are successfully separated our project into the separate layers, right? So here now let me add all my projects to the solution file. So since it is a .NET CLA, right, creating the project itself taking long time. If you are using Visual Studio 22, it must be pretty simple. Okay. Now to add all the projects to my solution file, here I want to use single command. For that, I cannot use normal command prompt. So please open the PowerShell. Okay. So you can add a command like .NET space SLN and name of your solution file. So here I forgot extension like SLN. Okay. Solution file and slash add open braces ls space hyphen r, and you need to specify star that represents your project folder slash star any name dot cs project. So this is nothing but it's going to add all the projects inside of this folder to this solution file. Okay, let me run the command. Okay, here you can see it is added to the solution file. The message is displaying it clearly. Okay. Okay, now let me open the project inside of the Visual Studio Code Editor. For that, let's open the command prompt and type command like code space dot. That's going to open us our project inside of the command prompt. And finally, our project architecture looks like this if you watch it on the IDE. Now we have to add the references, means which project depends upon which project. Okay, let's start with domain project. Domain is independent, so it is no need to get any project reference. Okay, but if I go for application, application project depends upon the domain layer. Okay, so let me add a reference for it. Okay, for Visual Studio, it is simple right click and add the reference. So here in the CLA, it's going to take big some lengthy commands we have to add here. Okay, my command is, if you observe here, .NET space add, and first I have to specify in which project I need to add a reference. So here I want to add a reference in application layer, application project, right? So I specified its folder and the project path also. Next, reference, and then which project reference you want to add. I want to add the domain. So I mentioned its folder and its project name as well. Okay. So reference is added. To confirm it, if you open the CS project of application project, okay, here you can see project reference. Okay. So domain project is referenced into application project. Okay. I want to add references into infrastructure project. So infrastructure projects depends upon our domain and application as well. Okay. So let me add both references. Here, if you observe, I am trying to add the reference of domain into my infrastructure. So let's add it. Okay. If I check the CS project file, here you can see infrastructure got the reference of the domain project. Now, same way in the infrastructure project, let's add application reference as well. Okay. Okay. Here we are trying to add the reference of application project into the infrastructure. Okay. Let's check again the CS project file. And here we can see both the domain and application projects got referenced into infrastructure project. Okay. And finally, in API project, I mentioned, right, API project only depends upon application layer. So let's reference the application layer project into the API project. Okay, here is my command to add the reference of application project into API project. Okay, let's check the CS project file of API project. And here you can see the application project added as a reference. But technically, we use only files of the application file in API project. But we have to reference infrastructure also into API. That is because infrastructure will contain its own DI files, means dependency injection registration file. But ultimately, we have to register it into the main DI, right? That main DI will be exist in our API project. So to register, only to register the DI file, we have to add reference of infrastructure file into API project. Okay. Other than that, never consume the files of infrastructure directly into the API project. Okay. Now infrastructure also I added. This is the command. Okay. Now if I check CS project of API, CS project of API, now it contains both application and infrastructure. So that's all about adding the dependent project references. Now I have to install two important NuGet packages into application layer and the infrastructure layer. Okay. Okay. The first NuGet package I have to install is Microsoft.extensions.dependency injection. So let me copy the command. Okay. And first I want to install that package into the infrastructure project. Okay. So for that, let me go to the infrastructure project path. Okay, now I am in infrastructure project path. I can add the command for installing. Copy the command and install the package. And package is installed. To confirm it, go to infrastructure project and here is the package reference I just installed. Along with this, we need to install one more package into the infrastructure. That is Microsoft.extensions.configurations. Copy the command, clear the terminal, add the package, install it. Okay, this is also installed. Let's verify it reference. So both the package installed successfully into infrastructure project. Okay, so same both the packages. Now I want to install it into application project. Okay, why I am installing these two packages means I will have some registration files like for DA in future. So I am going to set up a basic platform file for registering the DA in both the projects. Okay. Okay. Now I am in application project path. Here you can observe. Let's install DA package first. Copy the command, add it on the terminal and install the package. Okay, let's cross verify in the CS project file. So here is the dependency injection reference. Now let's inject iConfiguration package also. Copy the command, open the terminal, clear the terminal and add the package and install it. And let's check the CS project file. Okay. Now I am successfully installed two packages in application and infrastructure to set up a base platform for dependency injection. Okay. Now get back to infrastructure. Let me create a file like register service.cs services.cs. Okay, here is my class and I want this class must be a static and this class contains a method. This class will contain a method like public static void. I will name the method like configure infrastructure, just giving my project name. Okay, and this is like a extension method for iService collection. Okay, iService collection. Okay, import the namespace of Microsoft.extensions.dependency injection. Okay, and one more parameter. This method I am going to configure like iConfigurations. Okay, it is iConfiguration. Okay, that comes from Microsoft extensions.configuration. Okay, so in this file, we are going to register all our DI services in the future. Okay, now I have to register this DI service into my application layer. Okay, because application layer will be our API UI layer, right? So in the go to the API project, before going to API project, once build the project. Okay, for that, get out from all the project related path, come to the root path. Okay, like this root path and run like .NET build. So that will build all the projects, including 3 class libraries and 1 API project. Okay. And now if I go to my API project, let me close these files. And in the program.cs, here I have to register that register service of our infrastructure project. Okay. So builder.services.configure infrastructure. Okay. So let's import the namespace. Okay, and pass builder.iConfiguration as second path. Okay, so here what we did, we registered the DI file of infrastructure into our API project, and only because of this registration, we added the infrastructure reference into the API project. Other than this, we should not touch any line of code of infrastructure in the web API directly. Okay, that is a note. Now same way, let me create a register services file in application layer as well. Okay. So in the application layer, let me create a class like okay, here is my register services class in the application layer. So let's make this static. Okay, and let's copy the code since we have already created one platform file, right? Same way here also we need. Okay, so this is a platform file for registering DI services in my application project. Let's import the namespaces. Okay, now this method I will rename like not infrastructure, it is an application, right? Let's give same project name here. Okay, and here let's import the namespace. Now in the program.cs file, which is in API project, just like configure infrastructure, we need to register configure application also. Okay, builder.services.configure application. Okay, so builder dot configuration, and I have to import the namespace. We are done with registering the basic platform registration files of domain, application layer and infrastructure layer into our UI project. Next, we are going to implement or create the database context class. For this demo, I am going to create a table like beach, and it contains columns like ID, beach name, place, and image URL. And ID will be my primary key. Okay, create a table. So script is here to create the table. Now, using entity framework, let's create a database context to make a communication with our SQL database. Okay, so first let's create a table class into our application. Table class nothing but the entity. And we know entities we are going to create inside of the domain layer, right? So add a folder and name the folder like entities. Inside of the entities folder, create a class like speech.cs. So class name must represent our table name. Here is my class name. So let's add table columns as a properties into this class. Okay, let's copy the column names from here and add it here, and let's create the properties. Okay, I have created the property like ID. Now let's rename the properties, each name, and its type should be string, and it should accept nullable values. So postfix with question mark. Okay, place, and it is also string, and it should accept null values. Image URL, which is also string and accept null values. So let's remove these columns. So here I have created my table entity inside of the domain project. Okay. Now let's install NT Framework Core NuGet packages. Okay. In infrastructure and application layer project as well. Means we need to install them in two projects. So first I'm going to install the packages in infrastructure folder. So make sure your root path in the terminal is infrastructure project. Okay. So the first command I am going to install is Microsoft.NT Framework Core. Okay. Go to the .NET CLI tab and copy the command and add the reference here and install the package. Okay. Package is installed. Now let me install the second package. Here is the second package, that is Microsoft.NT Framework Core SQL. Okay, so let's copy the command, add it to our terminal, and install it. Now I have installed successfully in infrastructure project. To cross verify it, I can check the CS project file of infrastructure. So here are the two package references. Okay, now I can install NT Framework Core in application project also. Okay, to install in application folder, make sure you are in the correct path here. Okay, in the terminal. Let's install the NT Framework Core package first. Okay, package is installed successfully. And No need to install the SQL Server package into application. Just entity framework core is enough, right? Now I want to create the database context in the infrastructure. So, but infrastructure will depends upon the application layer. That means my database context interface must be created in the application layer. Okay, so first let me create the interface for my database context. Okay, in the application folder, create a folder like context. Okay, inside of the context, let me create my interface like my old DB context. I just specifying the name of DB context with respect to my database name. Okay, here is our interface. Now this interface will contain our table property and one method definition. First, let me define the table property. Okay, DB set any table property means our entity class must be registered as DB set and entity name, which we have beach, and give the property name and get. Okay, and let's import the namespaces. Okay, now I have created the property for my beach entity. Next, I want to define a method definition that represents save. Okay, so task int I will name like save to db async. Okay, this is my method definition. So now I got my interface. Let me create the database context implementation. So database context dealing with databases, right? So it must be created in the infrastructure layer. So inside of the infrastructure layer, let me create a folder like context. Okay. Inside of it, let's create our database context class that is like my old DB context. Okay, here is my normal DB context class. First, let's inherit DB context. So this DB context comes from Microsoft.NT framework code. And now let's inherit our my old DB context interface as well. Okay, let's import the namespace. Okay, I haven't given proper namespace. Let's go to my old DB context and it should contain context folder name. Okay, so let me import the namespace here. Okay, now let implement the interface. Okay, let me change this property like simple get and set. Okay, here in this method, I can call my real database context save changes async method. That is like I await save changes async method. Okay, so it must be written. Now let's add the constructor. DB context options and specify our database context type here, options and pass to base class. Okay, that is our database context class for now. Now let me add my SQL Server connection string in the UI project. In UI project, if you observe, we will have files like JSON files, right? So in the app settings dot development.json, let's add the connection string. So here by default, it supports a property like connection string. Inside of it, I can add new property, custom property for my connection string. I will add like my old DB connection. Okay. So here, add your database connection string. Okay, here is my connection string, and connection string nothing but key value pairs. Okay, let's see. Data source is a key, and its value should be our server name. In my case, it is my local DB. Next, initial catalog, that is a key, and its value should be database name. This is my database name, my old DB. And integrated security is the key, and its value is true. That means take Windows authentication as user credential. Next, connection timeout. So here specified like 30 seconds. Okay. So that's it. Very simple creating the SQL connection string. Now we had connection string also, right? Now my whole DB context must register under DI service, means dependency injection service. So where we have to create DI must be, for context class, DI must be registered inside of the infrastructure. Why means my whole DB context is here only, right? So here we have to register. Now services dot add DB context, and here specify our my whole DB context. Okay. And here we have to register the options. So options dot use SQL server. Okay. To this use SQL server, we have to pass the connection string. Okay. So to get the connection string, I can use configuration dot get connection string method. So this get connection string method will searches for the properties inside of the connection string in the JSON file. So here my connection string property is my old DB connection, right? I must add it here. Okay, that's it. I have registered my database context in DA, but in this project, we are going to access the my old DB context through interface. Means through interface, we have to create the DB context instance. So for that, let's register, okay, add scope and I my old DB context. So specify options like it must return the my old DB context instance as a response. So return options dot get service, and here I can specify the class name. Okay. So here we are doing means we are creating the instance of my old DB context and assigning to the my old DB context. Okay. So that's all about creating the context class in clean architecture. Next, we are going to introduce CQRS pattern into our clean architecture project. First, let's understand the CQRS pattern. Okay, CQRS pattern is a command query responsibility segregation. Okay, CQRS pattern, its main goal is to separate the commands and queries. Queries means operation to fetch the data from the database. Command means to save or update the data into the database. Okay. So In CQRS pattern, queries contains query entity, response model, and request model. Here, if you observe diagram, request model is optional. Okay. Same way, command also contains command entity, response model, and request model. Here, response model is optional. Okay. So here is the in detail description about the CQRS pattern. Okay. CQRS stands for command query responsibility segregation. CQRS guides us to separate our logical implementation into two categories, commands and queries. Okay, command specifies the operation like creation or updating of data into the data source, which means database. Query means specifies operation to fetch the data. Okay, in CQRS model, request and response classes are independent or owned by single operation. Here I told, right, CQRS query or command contains request model and response model, right? So each model or a class is designated to specific feature in the project. For suppose I'm having products, okay, and orders. So orders will have its own request model, products will have its own request model, okay. One model cannot share with other future, okay. So independent are owned by single operation, which means model classes cannot share between the commands. So between two different commands we cannot share, or between two different queries we should not share, and between two command and a query also we should not share. Okay, that means request and response are specifically we have to create for one functionality only. It cannot be shared. Okay. So from the diagram, one thing we must observe, request or response model optional. Here you can see optional for response model in the command and optional for request model in the queries. Same thing here explaining. That is because sometimes we will use query parameters or return a simple scalar type. In those cases, we won't create models. Why? Classes are optional means sometimes we can directly use the query parameters or scalar types means integer string query parameters there, right? So we can use them directly instead of creating a separate class. That is why they are optional here. Yeah, I think you got some basic idea, right? What is CQRS pattern? So the simple blind definition is it separates operations into two types, commands and queries. Okay. But CQRS pattern is more famous or recommended using along with mediator. Okay, if you observe here there is a mediator, right, diagram. Previously, without CQRS, this is our diagrammatic representation. Sorry, without mediator. So with mediator, our diagram looks like this. So what is the change means? Nothing will change. On top of CQRS, mediator will help us. Makes like a single pipeline for invoking the commands and query more easy way. Okay, but here there are no optionals here. Request model and response model must be defined. Okay, so there is no optional when we use mediator pattern. So here some definition about the mediator CQRS pattern. So mediator is another design pattern. Mediator builds with handlers that have capability to work with commands and queries. Okay. Mediator reduces lot of boilerplate code like injecting multiple services into the controller. Okay. If you use plain CQRS pattern, there are a lot of request model, response model, and handlers, right? All those classes models we need to inject it into our controller or we need to explicitly create into our action methods. Either these two things will happen means more number of managing the objects we have to do manually. But using the mediator will reduces those code. Okay. So injecting multiple services into the controller reduces multiple injections. Okay. Mediator provides single entry point that expects a request model. So based on the request model, corresponding handlers gets invoked. So it is simply a single pipeline, okay, where it only takes input request model, okay. Based on the request model, automatically through the registrations, it can identify which handler to execute and which kind of response must be returned from the job, okay. So based on the request model, corresponding handlers get invoked. We discussed. It works as a centralized communication hub. Okay. So basically, a mediator works as a centralized communication hub for interacting with either commands or queries. So normal CQRS pattern based on the query parameters or input type, request and response models are optional. But for mediator pattern, it is required. Request model is mandatory. Okay, response model also sometimes we can use scalar options, but request model is mandatory in CQRS. Okay, now let's introduce CQRS into our application, sample application. Okay, so first thing is I want to install the mediator package. So where I want to install means I want to install in the application, okay, and also in the API means UI layer project. Okay, first make sure your path is up to application layer. Okay, now I need to install this mediator package. So copy, add it in the terminal and install it. Okay, and the package is installed. To cross verify it, I can go to CS project of application project, and here I can see mediator package is installed. Now change the path to API in the terminal, and let's install mediator package here as well in the API project. So copy the command, paste it and install it. Okay, package is installed. Let me check in API CS project file. Okay, so here you can see the mediator package. Now I need to register the mediator service in the application project. Okay, we have a class like register services in the application project, right? So there I can register my service. Okay, services dot add mediator. Okay, to this service I have to pass my assembly name. Okay, so that it can automatically loads all CQRS related packages. Dot register service from assemblies method. To this method we should load assembly file name so that all mediator related files it can load, so that it can inject those files wherever our application required. Okay, to get the assembly name I can pass like assembly. Okay, this comes from references. Sorry, assembly. Okay, this comes from reflections dot get current executing assembly. Okay, so now the why current executing assembly means if our application are having some files related to mediator, if API is executing at that time, API this injection will take. If it is taking files from the application layer project, then application will take. So based on automatically it switches executing assembly means. Okay, so this is the single registration for mediator. We no need to register every individual mediator related file. Like this with single registration, that is enough. Okay, now in the application project, I need to install one more package, that is AutoMapper. We know AutoMapper, right, for mapping the object from one object to another object very easy way. So let's install the AutoMapper also into our application layer. First, make sure our path is up to application layer. Now this is the package I need to install, automapper.extensions.microsoft.dependency injection. So it will automatically install automapper library also. So let's copy the command, add it here and install it. And let's check the our CS project file of the application project. Okay, here you can see the here you can see the automapper package reference. Okay, now let's register AutoMapper service also. Okay, so to register the AutoMapper service, let's go to the our register service file. Okay, here only. So add AutoMapper. Okay, here we can simply pass our assembly dot get executing assembly. Okay. Okay, now let's create the files that represents our CQRS pattern with mediator. Okay, so what I will do in the application layer only, we are going to contain all the CQRS related files. So first, let's create a folder that represent my feature or the functionality. My functionality is related to beaches, right? So I am going to create a folder like in the application layer. I will create a folder like beach. Okay. So inside of it, first I want to implement a API call. Okay. That I want to fetch the records. So we are already fixed, right? We want to use the CQRS pattern. So for fetching the record means we have to implement the CQRS query handler, right? CQRS contains two operations, query and handler. For fetching, we have to use uh, query, right? Query, right? So let's create the query related files. Here you can see, right? CQRS contains query and comments, right? So now if I am working on query means I have to create at most three files. One file is query handler, another file is request model, another file is response model. These three files must and should I have to create. So inside of the beaches, let me create one more folder like get all beaches. Okay. Inside of it, I will create query handler for get all beaches, request model for get all beaches, response model for get all beaches. Okay. First, let me define the response model. Okay. So response model is nothing, almost equal to our beaches entity. So first, let's create the response model. So response model is like get all beaches. Okay. Dot get all beaches response dot cs. Okay, here is our response model. So this response model almost similar to our beach model. So let's copy the properties from our beach model. So copy these properties. So in my query operation, I have created my first file. So I have created my first file as response model. Let me create the request model now. Okay, let me create a request model like get all features request.cs. So in my case, my request model is empty, but we know we have to create request and response model mandatory when we use CQRS. But in my case here, get all beach request is empty. But in real time, we will have parameters like any filtering properties or pagination properties will definitely have. For this demo, what I am doing, I am getting all the data directly without any filtering or pagination. That is why my request model will be empty without any properties. Okay. But so here, mediator provides single entry point that expects only request model. So based on request model, corresponding handler gets invoked. So main thing in mediator CQRS pattern is request model. Okay. Cannot use the plain request model like this. We have to specify mediator type or inherit the mediator I request. Okay. I request. Okay. And to this I request, we have to specify the response model type. Okay. So response model is get all response model. Okay. So now this is mediator type CQRS request model. So it must inherit I request type, and there we have to specify the response type. Okay. So from the query operation, I created request model and response model, right? Now the pending is I have to create the query handler. So now let's create a class for query handler. I will name it like get all features query handler dot cs. Okay, here is my get all features query handler. And now if I observe the folder structure, see, now I have created three classes: query handler, request object, and response object. So we are in right flow. We are now this query handler must inherit I request handler. Okay, that loads from the mediator. Okay, and here we have to specify our request type and response type. So we know our request type is get all beaches request and get all beaches response. Okay, now let's implement the I request handler. So it will implement one method, that is handle. Okay, so whenever we invoke this request object from our mediator, we will write that code, not yet implemented. So if we just pass this object, it will automatically invoke the corresponding handle method. Okay, that is the beauty of the mediator. Okay, we can gather the information related to the query handler based on the request object. That is why one request object and one response model must be assigned to one query operation or one command operation only. Okay. So now let's implement our database fetching logic in this handle method. So let's inject our I MyVoltDB context first. Okay. Okay. Now using this MyVoltDB context, we can invoke our database and fetches all records from the beach, where results equal to, okay, MyVoltDB context beaches dot to list async. I want to use asynchronous call. Okay, async, sync, sorry, async. Okay, let's import the entity framework namespace. Okay, let's return this result directly. Okay, first thing, it is returning to list async. but my response type I have given like a single object, right? So I must change it to collection. So from here we must change the response type. So like list of get all responses. Okay. Now here also I need to change like list of get all responses. Okay. And here also we can change. Here we can change it to list. Okay. So one issue fixed. But here we are directly returning the beach type. But our output type is get all beaches response type, right? So for that I can use the mapper, auto mapper here. So first let inject the IMapper service into our constructor. Okay. So import the namespace. Okay. Inject the IMapper service. Okay. So I can use mapper projection technique, means directly inside of the query we can convert it. So using project 2, I think. And here we have to specify the type, that is get all each responses. Okay, and here we should pass the mapper configuration. So underscore mapper dot configure provider. Okay, so project to import the namespace. Okay, so to here we are converting beach model to get all beach response type. And here inside of it we are passing configuration provider, but till now we haven't created any configuration between the beach model and the get all responses. So we have to create a configuration or the profiler file. Okay, so here we will create one more profiler file. Okay, so get all beaches mapper file. Okay, this is my profiler file. Okay, here is our mapper class. To make it auto mapper profiler class, we have to inherit profile. Okay, that loads from the auto mapper. So here we have to add the constructor, and inside of the constructor we have to add the configuration mapping using create map. Okay, here first we have to specify the source and the destination object. So how to determine source and destination object is, here I want to converting beach type to get all beach response type. That means beach type is the source type and get all beach response is the destination type. Okay, same way. So here create map, first type will be source, second type will be the destination. So we know source, right? Source is beach model. So let me give the beach model source, and the destination. Destination means our get all response model. Okay, that's it. We are created the profiler file. This profiler file automatically get injected into the automapper service. Here we have registered, right, automapper service that will take care of loading those configurations. Okay, logical implementation is done. Let's create the get endpoint. So for that, let me create a new controller in our API project. Okay, so let me name it like beach controller.cs. Okay, here is our controller. So first let's inject the mediator service into the constructor of the controller. Okay, sorry, I mediator. mediator, I believe. Okay, let's try to import. So, okay, here spelling is little bit different from normal mediator. Okay, underscore mediator. So let's inject this service. Okay, so I mediator. Now let me create the action method to fetch the all records from my database. Means I am creating a get endpoint. Okay, public async action result. Okay, task, I believe task we have to give asynchronous call, right? And get async. Okay, and decorate with HTTP get method. Okay, and here what we can do means where result equal to mediator dot send. So wherever we use or invoke our CQRS, we simply call this line of code. I mentioned, right, mediator works as a center hub like a single pipeline. So in this send method, we have to pass our uh, request object. Okay, here we have one request object, right? So this request object must be passed. If we assign request object, it will automatically invoke the corresponding handler method. Okay, that is why request object is not a normal request class. It inherits iRequest model because whatever this request model and the response model registered with iRequest, right? So that can uh, automatically find out the handler based on the I request handler because here we again specify request object and response object. Everything will be automatically taken care by the mediator library. Nothing we have to do. We just understand the flow will be like this, like this. So on creating the request object, it can invoke the corresponding request handler. Okay. Now I simply pass the object of the my get all features request model. Okay, and finally return the result. Now once build entire project, so there are some errors. So where I am getting error, each name is not defined in IMyOldDB context. Okay, go to IMyOldDB context. This beach name doesn't recognize it because of we have created one beach folder in application project, right? So it is getting conflict with that. Okay, now what I will do, I will give fully qualified namespace. Here I remove dot. Okay, and remove this using. Okay, let me rebuild again. .NET build. Okay, no errors. Our application is built successfully. Let's go to the API root path. Okay, here let's run our API project. And here we can see our get endpoint, right? Click on it and try to execute. I have already inserted a sample record into my database. If everything goes good, I will get response data. Okay. So something is not working. System action instance. Okay, okay. I haven't awaited. Here I haven't awaited. So let's add await here. Okay. So rerun my application. Try again. See. 200 and I am getting some response. Beach name, place, ID. Okay, API response. That means my get endpoint is successfully executing. That means we have implemented a sample project using clean architecture and using CQRS pattern with the help of mediator. Okay, but till now we have discussed only about query operation, right? Means getting the data. Next, we are going to discuss about CQRS command operation. That means saving or creating data into the database. So to implement command operation, we need to create request model, response model, and command handler. Let's create them. Okay, in our application project for query operation, we have created get all beaches files, right? So inside of the beach folder, let me create one more folder like create beach. Okay, so these files for inserting or creating the new record into our database. Okay, first let me create the response model. Okay, so for this create operation, I am not going to create explicit response model because I just want to return newly created item ID. Okay, which means Scala primitive type. So I am not going to create a create response object here. So let's directly create the request object. Okay, create beach request.cs is my file name. Okay, this is my create beach request. So let's add the properties. So this create beach request will be used as a payload object. Okay, so let me open beach entity. Okay, accept ID value because I am going to create new record, right? So from user payload, I no need ID value. I just need remaining properties. Copy these properties, add it here. Okay, so I have created payload object. Now to make it mediator request object, it must inherit I request. Okay, and here I mentioned I am going to return simple integer, which means item ID, right? So here I can give response type like integer. Okay, now let me create my command handler class. Okay, create beach command handler. Okay, now let's inherit I request handler. Okay, that comes from mediator. Now specify the request object and response object. Our request object is create beach request and response is simple integer. Okay, now implement the handle method. Okay, now my payload object is create beach request, right? Now I have to map it to each entity before saving into the database. So for that, let's create a profiler for our create beach also. Okay, so let me create a profiler class like create beach mapper. Okay, here is our create beach mapper class. Now let's inherit the profiler instance that loads from auto mapper. So profile, and let's add constructor and register our mapping source and destination object. Okay, create map, and in my case source is my payload object create beach request object. Okay, Okay, here let me give the actual namespace. Okay, and now let's define the source object. I mentioned, right, source object is our table class, that is beach. So I can give okay. My mapper class is ready with the configurations. Now let's get back to our create beach command handler. Let's inject our DB context as well as IMapper service. Okay. Okay. Let's inject as well and assign it here. Now let's inject IMapper service also. Okay. IMapper. Okay. Now inside of the handle method, let's implement our insertion. So I can call my whole DB con. So first let's map the create beach request object to our entity object. Okay. So where new beach. Okay. So create map and specify the destination object. Destination object is our beach model. Okay. And here pass our payload request object. Okay, now we successfully converted our payload object. Now I can add it to the DB context. Okay, let's call save changes async method. And finally, let's return my newly created item ID as a response. Okay, so we are done with our command handler logic. Okay, so here you can see the files of our command handler. Okay, now let's create the post endpoint in our controller, each controller. Okay, public async task reaction result post async. Okay, it should be decorated with HTTP post verb. Okay, it should contains our request object. So what is our request payload type? Create beach request payload. Okay, now I can use my mediator query iMediator.send. So send simply expects just our request object. Here request object is our payload. Okay, so where ID. Okay, newly created item ID. I will return it in the response. Okay, let's try to insert the new record. Okay, here you can see the post endpoint. Okay, and let me try to insert a new record. Okay, here is my sample payload data I just added. Let's click on execute button. See, I got 200 response and some ID value. Just try to execute our get endpoint to confirm that record is inserted. And here is the new record we just inserted. Okay, from this we can understand we are successfully implemented the command handler of the CQRS in our clean architecture project. Okay, and finally next we are going to implement the validations into our API using the mediator iPipeline behavior middleware. So in this video we are going to implement mediator iPipeline behavior. So what is iPipeline behavior? The iPipeline behavior exactly works like ASP.NET Core middleware, but it start executing and end execution happen within iMediator. So the iMediator.send usually used to invoke query and command handlers. So if you implement iPipeline behavior, then the logic inside of it start executes, then invokes query or command handler, later again go through pipeline behavior and executes the end logic. Okay. Basically, pipeline contains two sections of code. Okay. One section executes before executing the query or command, and another section execute after the completion of the query or command execution. Okay. So this is the diagrammatic representation. Okay, here you can understand whenever mediator query triggers, first it will execute the iPipeline behavior if they exist. Since iPipeline behavior contains two sections, right? So first before request gets executed. Like that, if you have n number of pipeline behaviors, if you configured all the starting code of pipeline behaviors will execute. Then query or command execute. After the completion of query or command logic execution, it again travel back to the pipeline behavior where the end logic execute. Okay, so it is almost like our middlewares only. Okay, so using iPipeline behavior in our sample, we are going to implement validations. Okay, so we will implement validation for validating this create each request payload object. So first, so for the validation, we are going to use Fluent validation library. Let's install its NuGet package. Okay, the required library is Fluent validation dependency injection. It will implicitly also installs the Fluent validation. Okay, copy the command. And we have to install this package in our application project. Okay, sure terminal make sure terminal is pointing to the application project path. Now add the package. Okay, so copy the command, paste over here and install it. Now to cross verify package installed or not, go to our application project and explore the CS project file. And here you can observe Fluent validation dependency injection library reference. Now let's register Fluent validation service in the register service file in application project. Here is the register service file. Services services dot add validation validators from assembly. Okay, that is coming from Fluent validation library. Okay, and just pass currently executing assembly name here. Let's create a generic class that inherits iPipeline behavior, and in that class we are going to implement our request object validations. So inside of the application project, let's create a new folder like common. Inside of the common folder, let's add a new class like validator behavior. Okay, and this behavior is a T request and T response type, a generic class. Okay, and it will inherit pipeline behavior. Okay, and that comes from mediator. Nothing but we are implementing mediator middleware for validation. Okay, here also I can specify T request and T response. Generic for any kind of request object, we can use this validator. Okay, and where T request and that inherits our I request from mediator, where we specify T response. Okay, and let's implement the iPipeline behavior. Okay, it contains handle method. First thing, let's inject iValidator interface as a collection to capture the errors. Okay, so private read only enumerable of iValidator validator of we are validating request, right? T request. We have to specify the type. Okay, underscore validator, and let's import the namespace that comes from Fluent validation, iValidator. Okay, add constructor and inject the enumerable of our validator. Okay, validator of T request. Okay, let's go to our handle method. So here this will captures any validation rules are applied to the request or object or not. So in the handle method, I will check for that request any validation is enabled. Okay, so if at least one validation is enabled, this if gets executes. Now where context equal to new validation context for my request object. Okay, which is T request, and I must pass my request where validation results equal to await Okay, task. Then all. I want to check all validation errors. Okay, so I can pass my validators object and select each individual validation. So I can validate each individual using validate async. Validate async. Okay, and we can pass our validation context and the cancellation token. Okay, so let me explain what I am doing here. So if you observe, validators will collect the all validation rules. Means, for suppose I have create object, right? So I have three properties. If I enabled three validation rules for each property, okay, all these three will be referenced into this validators collection. Okay, so here what I am doing means I am looping the each individual validation, a validation rule, and checking against the request object. Okay, since it is a async validate async, right? So I want to do validation for all the properties. That is why inside of when this task will complete, when every property and every validation rule is executes. That is why we are using task.when all. Okay, so we will get all the validation rules execution here. Okay, now finally what I can do, from here I can check for any failures in the validation. So to check the failures, validation results, okay, dot select many. I want to gather all the validation failures. Okay, dot errors. Okay, and I want to check where errors are not equal to null. Okay, and to list. I'm just gathering the error results. Okay, now if validate failure results, just I will check the count. Okay, count not equal to 0 means there are some exceptions. Then I can simply throw, I will throw the exception, means I am terminating the execution flow of our request or query command. Okay, fluent validation dot validate exception. Okay, and to that exceptions I will pass my failures. Okay, and finally I have to write return await async. Sorry, await next, I believe. Okay, so that's it. I have mentioned, right, middleware contains this must be out of if condition. Sorry. Okay, I have mentioned, right, our iPipeline behavior is also middleware, right? So it contains two parts of code where request execution code and response execution code. Here we don't have any response execution. So this part will first executes before our query or command handler execute. Okay, first this will executes. Here it is awaiting for next, right? Here it will stops executing further and it will goes to our query handler or command. After that, okay, after that it again return back to the pipeline. But here again we don't have any logic for execution after this await next. we are directly returning. So there is no code to execute. That means it will again goes back to our mediator.send method in the controller like that. Like this flow we have seen, right? Like this, it will go back to the mediator.send method. Okay. Let's register my validation behavior. Okay. In the register service. Register at request level. Okay. Means I am going to use transient. Add transient for every request. Okay. Indicate my validator behavior. So I will register like type of pipeline behavior. Okay. Let me copy from here. Okay, and it is a generic type, right? So just open arrows, okay, and separated by comma. No need to specify the request type and response type because they are already generic types, okay. And next type of and import the namespace. Okay, now we have to register our validator behavior also just like pipeline behavior, okay. Okay. Now I have created the iPipeline behavior where it validates my request. Now finally let's add validation rules on my request object. For that in the create beach, let me create a new class like create beach validator. Okay. This is a normal class. I want to just apply the rules on my request object. Okay, here is our create beach validator class. Now it should inherit abstract validator, I believe. Okay, that comes from Fluent validation, and we have to specify the request object. The request object is create beach request. Okay, now let's add constructor. Inside of the constructor, we can access our request object properties. So let me access like can use. First, I have to apply a rule to access. Okay, so here, see, all my request object properties are coming. Here, I will specify beach name. I will apply a rule. Okay, I will apply like not empty. Okay, that means beach name is mandatory. Okay, so this beach create beach validator automatically recognized by the Fluent validator. Okay, how it will recognize means here we have already registered the service, right? Validator from assembly. So it will read all the Fluent validators that we create in the project. Okay. So that's it. We are done with our iPipeline behavior validation implementation. So let's test and close this. So let me run my API project. Okay, let's try to create one new record. Okay, let me send empty beach name and remaining properties are cached. Since I applied only rule on beach name, right? It should not be empty. Let's try to execute the endpoint. See, I got 500 internal server error. Fluent validation. Beach name must not be empty. That makes sense, right? That means our validations are firing. Okay. So that's all about mediator pipeline and where we can implement API validation. Thank you so much for watching this video. I hope this video delivered some useful content to you all. If you like the video, please do support by subscribing to channel. Soon we are going to meet with new content. Until then, signing off.